Hi guys, so welcome to the Indices chapter. Now I've split indices into two different lectures because the questions that we're going to be covering are going to be fairly involved. So I wanted to split into two different lectures so we have enough time to cover everything that we need to cover without having to rush through the questions. So let's have a look at the very first question. It says, at the beach there are 5.3 times 10 to the power of 10 grains of sand, out of which 0.3% are washed out to sea each hour. Now, how many grains of sand are there or are washed out to sea every single day? So let's have a look at this. So we have 5.3 times 10 to the power of grains of sand. Grains. Now, 0.3% of the 5.3 times 10 to the power of 10 are washed out to sea every single hour. So let's do this math. So we have 0.3%, which is the same as 0.003 times 5.3 times 10 to the power of 10. Now, 0.003 is simply 3 times 10 to the power of negative 3, as we know, times 5.3 times 10 to the power of 10. Now, using our knowledge of first index laws, we know that 10 to the power of negative 3 times 10 to the power of 10 is simply 10 to the power of 7. And then 3 times 5.3 gives us 15.9. So 15.9 times 10 to the power of 7 grains get washed out to sea every single hour. Now, the question, however, says how many grains of sand are washed out to sea every day? Now we know that 1 day is equal to 24 hours. So 15.9 times 10 to the power of 7 times 24 is the number of grains of sand that's being washed out to sea every single day. So let's have a look at what this equates to. 3.82 times 10 to the power of 9. So, to answer this question, therefore, 3.82 times 10 to the power of 9 grains of sand are washed out to sea every day. Excellent. Let's move to the next question. Okay, this question says, if the human body produces 7 times 10 to the power of 8 red blood cells every single day, how many blood cells have been produced after 3 weeks? Okay, so we have 7 times 10 to the power of 8 every single day. Then we have to look at it from 3 weeks perspective. So 3 weeks. And 3 weeks we know is simply 21 days. So if 7 times 10 to the power of 8 blood cells are produced each day, then in 3 weeks, it'll simply be 7 times 10 to the power of 8 times 21, which gives us a value of 1.47 times 10 to the power of 10 red blood cells. So, to answer this question, therefore, 1.47 times 10 to the power of 10 red blood cells have been produced after 3 weeks. So again, guys, takes about 10 seconds, but it really just tells the person who's marking it exactly what you're calling out to be the answer. Fantastic. Let's move to the next question. Okay, so this particular question says, if the number of red blood cells being produced each day is 7 times 10 to the power of 8, how many are being produced every hour? So once again, we have 7 times 10 to the power of 8 in 1 day. They want to know how much it is in 1 hour. Now guys, since 1 hour is less than 1 day, obviously, we actually need to go through the process of a division. So we need to do 7 times 10 to the power of 8 being divided by 24. Why is it 24? Because one day is equal to 24 hours. Now, if we were to look at it as, ratios, remember guys, at this level, we're going to be covering questions that involve knowledge from multiple different topics, not just the topic that you're working on. So this is indices, but if we were to look at it from a ratio perspective, imagine, there is 7 times 10 to the power of 8 in 24 hours, and we're trying to find out how much it is per hour. Then going from 24 to 1 is divided by 24. Similarly, on this side, it'll be divided by 24 as well. So that's another way for you to look at it. So always, guys, take the information you've been given, write it out in a format that you're familiar with, and once you do that, you might get some ideas as to how to approach that particular question. As for me, I know straight away that I need to do a division here. So 7 times 10 to the power of 8 divided by 24 gives me a value of 29.2 times 10 to the power of 6. Therefore, 29.2 times 10 to the power of 6 red blood cells are being produced every hour. Okay, moving to the next question. So this question says, if the entire human body has 2 times 10 to the power of 12 cells altogether, what percentage of cells are red if there are 7 times 10 to the power of 10 red blood cells? Okay, so let's write this out again. So we have 2 times 10 to the power of 12, that's all together, so total. Then we have 7 times 10 to the power of 10, which are red. So the percentage of the two would be simply 7 times 10 to the power of 10 out of a total of 2 times 10 to the power of 12 being multiplied by 100 here. Now, using our knowledge of the second index law, we know that 10 to the power of 10 divided by 10 to the power of 12 simply gives us 7 times 10 to the power of negative 2, because 10 minus 12 gives us negative 2, leaving us 2 at the bottom, and then times by 10 to the power of 2 in this case, because 100, as we know, is simply 10 squared. And then now, reverting back to our first index law, we know that 10 to the power of negative 2 being multiplied to 10 to the power of 2, the powers simply get added together, so negative 2 plus 2, giving us 7 times 10 to the power of 0 divided by 2. So 10 to the power of 0 is simply a 1, so 7 times 1 over 2, which is simply 7 over 2, which is equals 3.5%. Therefore, 3.5% of all cells are red. Now, I'm sure that this is probably not the right answer. Remember, guys, I've just completely made up these numbers in order to formulate these questions. So, guys, this brings us to the end of the very first lecture for indices. I decided to split them up just to give you guys a little bit of a break. We'll pick it up again in the second lecture, where we'll go through a few more questions of different types. So thanks, guys, and I will see you in that lecture.